Hi everyone! Nowadays, 10G Ethernet is becoming more common on edge devices than ever before, but there's a problem. Even with 10 gigabit Ethernet hardware available, we still can't fully utilize the speed. This shows that the real challenge isn't the hardware, but the software that create bottlenecks. To solve this challenge, we introduce SocketXpress, a custom Linux network socket library designed to work with Design Gateway's TCP Offload Engine. With TCP tasks offloaded from the CPU, applications can finally unlock the true performance of 10G Ethernet on edge devices. This is how our system works. To accelerate a TCP connection, we use LD preload to intercept application socket API calls and redirect them to our hardware accelerator, while other network protocols continue using the standard Linux network stack. In this demo, we'll be running applications through SocketXpress on the Kria KR260 FPGA board. The setup included a KR260 board, a test PC, and a switch with a gateway, all connected together over 10 gigabit Ethernet links. After you set up the system as shown and boot up KR260 with the provided Ubuntu image, running dmessage shows our TOE and 10G EMAC drivers have initialized successfully with the hardware detection. You can see our network interface is present, but currently down since we don't have anything connected yet. With the cable plug-in, the interface is now up and running. You can connect to the FPGA board via SSH as well. Now we are ready. Let's use our Socket C program to test the performance of 10G Ethernet using the network stack. With the server open on the test PC, let's first run our TCP testing program using the standard Linux socket. This will go through the traditional network stack path as shown in the diagram. Here, the transfer speed is just about 3 gigabits, but CPU usage goes up to 140% across 2 core. Now let's run the same test using our SocketXpress library with LD preload. This redirects the TCP traffic directly to TOE hardware. The TOE needs a specific source IP address, so we add -b TOE IP to bind the source IP address using the socket bind function. With hardware acceleration enabled, we achieve significantly higher throughput while reducing CPU utilization. Here, the speed jumps up to 9 gigabits, and CPU usage goes down to about 110%. Now let's showcase a real-world application. We'll browse the web through links through our SocketXpress. Since links cannot bind a source IP directly, we specify it through environment variables with LD preload. The HTML page renders, and we can navigate through links normally. Also, you can use curl to fetch and display HTML content. SocketXpress demonstrates how hardware acceleration boosts network throughput to nearly the full 10G Ethernet bandwidth while reducing CPU load, and works with existing network applications through LD preload. Thank you for watching. Empower your edge devices today. Visit the Design Gateway website to discover the future of high-speed connectivity.